It's time for PerfBytes.
What the is PerfBytes?
The fourth square meal of the day. Filled with PerfBytes. Waffles, microwave ready. Blobbity blah, blobbity blah.
Add nutritional value to your brain.
It's time for PerfBytes with your hosts Mark Tomlinson and James Pulley. PerfBytes. Whatever.
Hey, it's time for PerfBytes, and this is a very special edition of PerfBytes for one reason and one reason only. Broadcasting live from the Central Command of PerfBytes in Nashville, Tennessee. My wonderful co-host and very attractive young man himself, James Pulley, is there. And James, who are you? Where are you?
I'm sitting right next to Scott Moore.
Scott Moore, buddy Scott Moore. Mr. Moore, how are you doing, man?
I'm well, Mark. How are you, buddy?
Very good. It's nice to have you actually on the show, not just via Skype or on a phone or something. You're actually in your studio. I'm in my studio. We're all in a studio someplace broadcasting about PerfBytes. Today's show is all about what is it? What was it? What the hell we're gonna? James? What was the topic?
Memory.
Oh, that's right. Memory. We're going to talk about memory. Whatever the thing was about memory, I don't remember. Well, anyway, we'll get back to it when we get to it. The thing about computer memory, not necessarily my own memory, although I'm sort of losing it. That would be great. But as usual, James, we need to kick the show off with what's been happening. It's summertime. It's vacation time, but things are still happening in the news, right?
A lot of it is conference-related, stuff coming up, stuff just ended. For those of you who are looking for a conference out in November to spend that end-of-the-year money,
yes,
consider the SC13 Supercomputing Conference to be held in Denver, Colorado, November 17th to the 22nd. Despite the number 13 in the title, it is the 25th annual conference for the supercomputing community.
Yes.
If you are a person interested in high-performance computing, you need to put this on your bucket list to attend at least one time. Go, listen, learn, have some takeaways. You'll be a better performance engineer as a result. Next up, the Black Hat 2013 conference just concluded. Some cool things that I saw coming out of the show included some electromechanical pin crackers. Think of someone who's got a pin on their phone, and you want to crack that. If it's a 4-digit pin, you're looking at 9,999 possible combinations.
Yes.
Who are you going to hire to sit there and do it repeatedly, consistently, and track all the differences? You're not. Basically, that's where these devices come into play. Think of mechanical fingers to just sit there and watch and look for changes in the screen.
Yeah.
And it would be for any pin-based item. So it could be an ATM, it could be a phone, it could be your tablet. Also, an update to Tor, the famous anonymizing proxy, has been updated to Tortilla. So that's also a big, they update it. They add a couple letters, Tor to Tortilla.
No, I thought there was one tortellini. I think tortellini.
No, that's a dish best served with carbonara sauce.
Okay, all right, yeah, and a Chianti of some sort.
Exactly.
Okay.
And we have an observation from Ron Foster, a PerfBytes listener.
Yes.
Is that the Black Hat Conference had excellent swag. So if you're looking for a conference to attend next year and all you're looking for is T-shirts, marshmallow guns, all sorts of things like that, Black Hat 2014. Next up, SOSTA. Well, we've had a lot of SOSTA news over the year.
Yeah.
They've got a new $30 million round of funding, which brings their total funding level to about $63 million. And this is proof positive that when you have a tool with a high ROI, that demand will exist, and it can be both a market maker and a market mover.
Well, that's very interesting. But James, Scott was just at the Agile conference. I thought test was dead. Isn't testing dead?
Well, that's only with the beret-clad, gun-toting revolutionaries of Agile.
Yeah, so I'm wondering maybe the SOSTA guys, which is great news for them. And but yeah, when anyone says test is dead, I'm going to give them a $30 million earful called SOSTA.
Exactly. Yeah. If the investment community thought test had no value, there would not be an additional $30 million round of funding.
Yeah.
But I think what is best stated out of this is IBM, Borland, HP, are you paying attention?
Wake up
Are
call.
you nervous?
And they should be, because the news right before this for SOSTA was that they've entered the Magic Quadrant in the upper right corner.
Yeah, so they've got two nice marks right there, which indicates critical mass, which means people are going to be looking at them as an alternative.
Yeah.
Next up, you're going to love this, Mark.
Really?
A high-speed kerfuffle.
Will you please say the word kerfuffle again?
Kerfuffle.
Yeah, well, that's good. I like that.
So you're probably familiar with 1 gigabit Ethernet. You may be familiar with 10 gigabit Ethernet. Did you know that there's 100 gigabit Ethernet?
Yes, I did know that. We mentioned it back on the network performance.
That's right. There was a tool
gigabit
announcement, and some people have done some 100 gigabit Ethernet testing. Well, once you get above that, there's a little bit of dissension in the community over where they head.
Yes.
Do you go straight to terabit Ethernet, or do you make a stopover at 400 gigabit Ethernet? Either way, you're looking at Category 1 glass fiber to whatever interface you're looking at.
Right.
But it's an interesting discussion from a performance perspective. I would encourage people to go out and kind of read the threads associated with this and the arguments being made, one versus the other. But a lot of the arguments have to deal with the growth in the amount of data flowing through the system.
Yeah. And
why is that growth occurring? Remember our discussion on LAN versus WAN optimized apps?
Oh yeah.
Bad apps on the network, you're going to move your costs someplace else if you're going to maintain performance.
Yep. All of those app developers with performance problems, and they don't really know what their code does, but they just blame it on the network. Oh, it must be the network. If we had terabit speeds and
they
bandwidth,
would still blame the network.
They would still blame the network, but it's going to be obvious.
So, last news of the day, I'm going to turn over to Mr. Moore.
Thank you, James. I'm going to do a shameless plug here. If anybody's interested, Wilson Marr of HP and wilsonmarr.com fame and myself are putting on a webinar on August the 20th. If you want more information about this webinar, you can send an email to events@northwaysolutions.com. The webinar is going to be titled Preparing Your Applications for Heavy Load. It's the same thing that you guys have been talking about when you had the show on point load, things that you can do to prepare your site or your application when you know there's going to be a press release, or just in case a celebrity happens to mention your website or your application on the air somewhere. What are the things that you can do to prepare for that? I am going to be using some of the ideas that you guys had come up with.
Are you going to pay Kim Kardashian to tweet out your show?
I've thought about that, but Wilson's so sexy on his own. I don't think I'm going to need to do that.
He is. His intelligence is very attractive.
And I have to say, I've spent some time with Wilson this past weekend. He was here in Nashville for the Agile conference, and we got to talk. We get along really, really well. He's a great guy. So that's going to be a Tuesday, August the 20th, and I believe it's 2 p.m. Eastern time, but you can just send me an email at that email address. I'll tell you more. But it's basically getting down to planning. How do you properly plan for point load? And the obvious best thing that you can do is learn how to plan to do proper performance testing. So we'll be diving into some of those ideas about planning and process.
Cool. And Scott, will you be inviting anyone from the marketing department to attend this webinar?
There will not be a marketing person on there. I guess I would be the closest thing to a marketing person.
No, I mean, shouldn't your attendees include the marketing people?
Yes. With only an hour, we can't dive down into all these technical details. We really need to talk to the sales guys, the marketing guys, or the developers, whoever's getting ready to ramp up for this. And things that they need to know. So, awesome. You're absolutely right, Mark. Marketing people should be the first ones on the call.
Yes, I'm going to call your CEO if you don't tell us what's going on. Awesome, Scott. That's great topical news. Events@northwaysolutions.com if you want more information. All right, talking about memory. When it comes to performance, every application, as we talk about CPU, disk, network, and memory, right? So memory is a really interesting system resource. It's one of the most interesting ones because, first of all, it's probably been the fastest source of information storage and movement because of bus speeds compared to even stuff moving, let's say CPU and disk, moving stuff into the disk or moving stuff on the bus or moving things on the network. Memory is like, for as long as I've been doing this in 20 plus years, it's always been, hey, if you can do that in memory, quote unquote, in memory, it's going to be really fast, as opposed to everything else that's just absolutely slow. And even though on the news we're talking about, terabit network connections or 400 gigabit Ethernet, still the network comparatively and memory has also been getting faster and faster and faster and faster. So,
and Mark, let's also not forget that it's been getting cheaper and larger.
Cheaper and larger and faster. Isn't that the bigger, better, faster, more?
Lions, tigers, and bears, oh my.
Exactly. So the thing is, no matter how fast systems get, we tend to still make more and more complex systems. So sort of relatively, we can do, old kind of apps that only move 3 fields from here to there and back are very, very simple to do. But now you've got mobile applications. I mean, some of the complexity of pulling data back and aggregating data from multiple sources and loading them on my little mobile device, even in mobile, I mean, there's an amazing amount of stuff that gets loaded into memory. And we want to talk about the basics of what you would do when it comes to learning how to improve the performance around your application when it comes to memory. And we came up with 4 things, and I'll just put them right out there. The first one we want to talk about with application memory is just garbage collection. And basically, any garbage collection or multi-generational virtual machine or language has garbage. We create garbage when we do processing, right? We create objects and we need to dispose objects and put them into the garbage and take them out to the curb. And there's not really a recycling program. I guess technically there could be a recycling program. Do you have to separate? Do you have to separate your objects, the plastic from paper?
Only where government demands that you
Only where
separate.
government demands you separate those objects. That's right. The second thing we'll talk about is caching, right? So if we can not talk to disk or not talk to the network and actually cache something and store it in memory, fantastic idea, right? So I don't have to actually jump out of the processor or memory. It's right there, caching. We'll talk about memory leaks, which means when things run, after like your machine's been on for several days or the servers have been up for hours and months and whatever, and then suddenly you run out of memory and the system crashes. We'll talk about memory leaks, and then the last thing we want to talk about is swapping. So let's talk about garbage collection. Scott, if I create a bunch of objects in a virtual machine, when I'm done using those objects, what happens to them?
Well, you got to flush them out.
Okay.
Well, hopefully I've marked those objects that I no longer need them, so they can be flushed out.
Right. So
I'm engaging in some sort of practice where I'm cleaning up after myself.
Yeah. So you guys both brought up the 2 key main words in garbage collection. One, Scott, you mentioned flush, and James, you mentioned marking something or marking them, not mark me, but mark them like put a mark on them, right? And those are the 2 main things. So when you create an object, a physical object, let's say it's going to be a memory structure, and that object is going to be a string, and the string is 1 megabyte in size. 1 megabyte string. It's like a giant view state, right? Let's say it's a .NET view state. And that object is huge comparatively. I have to actually allocate physical memory. And James, what does an application have to do in order to allocate physical memory to store that object?
Well, first, you have an interrogation to the operating system to see if the memory is available. Mm-hmm. And then there is a direct physical allocation of a block of memory to store this item. And then finally, there is a movement from wherever it's coming from into RAM. So it's usually coming from a network device or coming off a disk and into physical RAM. That memory is then marked as swappable or not, which gets to our later discussion.
Right.
And then it becomes useful to you as some place that you can reference, usually by a memory handle.
Right. So you get a handle from the kernel being the operating system that says, I've got 64 gigabytes of RAM, but your Excel spreadsheet over here is, if you've watched in Task Manager or in Top, or you've seen sort of memory growth, when you open more applications, you see the little line goes up, the available bytes comes down and the private bytes goes up. As the private bytes are allocating more things, the kernel is saying, I will give you, it's sort of like a lease in the real world. Like I'll let you have this memory for this amount of time, and here you go, and it's allocated to your process. And then your process, if it's a database or a spreadsheet or an application or a JVM, .NET, you name it, then it'll allocate that. So it has to actually take up physical memory and sort of reserves and controls that memory location in RAM.
And Mark, I think it's useful to talk about how the virtual machine adds an additional layer on top of this. For performance, what has happened when you start up a .NET virtual machine or a Java virtual machine or a database server for that matter, is they will grab a block of RAM for their own management. So they have their own internal block, and then the virtual machine is managing it inside of that block.
Yeah, it's sort of
so
like
you're adding another layer on top to access the actual physical RAM.
Yeah, like a broker. It's like you don't actually talk directly to the kernel if you're running on top of a virtual machine. And when we say that, we mean the JVM or the .NET CLR. So let's say we do a 5-minute session on the application. We've been playing around with this object on the front end, and then we close the browser, and it closes down the session. And that session, which is another object, has that 1 megabyte string that we had sitting out there in an object. And after some amount of time, James, you mentioned marking. So when I say dispose this object, I could just close off the interface to it, shut down a parent object, and then that string just kind of hangs out there. And when you mark it, it says, you know what, I'm done using this object. Go ahead and throw it away whenever you get to it. So what's the difference between marking something and then not actually cleaning it up versus like if we explicitly dispose, like if we do disposing or freeing up of memory handles, like if you're writing stuff in C, you explicitly free up that memory and boom, it goes back. Garbage collection is sort of lazy, right? It's like me on the weekend. I'm not going to actually, just throw it in the waste bin. I'm not going to take the garbage out until the end of Sunday night, right?
Well, historically, one of the biggest problems with memory management is that people would write applications in such a way that your cleanup code for deallocating your memory might not be hit under certain conditions.
Right.
And that led to what's called memory leaks.
Right.
In this case, where memory is constantly growing, you're allocating memory, but you're never deallocating. What happens at the more primitive level is you actually physically free the memory using the memory handle.
Right.
In the case of the higher level operations inside of a virtual machine, what you're doing, Mark, as you indicated, is you're disposing of the object. But if your code still never reaches that fork where we dispose of an object one way or another, we mark it or dispose of it, you still have a potential for having a memory leak where you allocate an object that sits in RAM and it never gets cleaned up.
Never gets cleaned up.
Reboot the VM or the physical machine.
Right. So keep in mind, these objects just hang around in time, as James suggests. So the first thing to really know about garbage collection is that there's an inherent belief that it's faster to just do the work you're doing with the objects you create and use, and don't spend any time, don't chew up any CPU managing the garbage. Just sort of toss it off into this multi-generational kind of thing and allow a separate pool of threads to come along asynchronously and clean up. It's like my little army of minions, right? From Despicable Me, little minions, go clean up the garbage. And they would sort of do it asynchronously. Now, here's the number one thing about memory and performance that hits us from garbage collection is if you don't take out the garbage, if your minions get really lazy and the garbage builds up and builds up and builds up and builds up, there could be a point where you hit something called stop the world. And stop the world starts to say, it's a state within the JVM that says, you know what? I got so much garbage to clean up because we've sort of been deferring all of that work. I kind of need to stop all the threads from creating new objects and doing new work, the things that are actually, making your web page work and making the application work. You have to stop everyone just so you can come back to consistency and clean up all those old objects. So these things get older and older and older, and if they pile up and you don't have enough garbage collection threads for parallel garbage collection, then you'll fall behind, and then you'll end up in this stop the world state. Well, stop the world is really bad because let's say you're doing 1,000 transactions per second. You instantly go to 0 transactions per second. So that's a bad performance thing, right, James?
That would be a bad performance thing.
James, we'll take a quick short break here for a word from the NewCo sponsor, and we'll be right back.
Okay.
Hosting for PerfBytes.com has been provided by NewCo, New Centers of Excellence in Performance Engineering, PowerTest Professional Services, The Script Farm, LoadRunner by the Hour, Videratech, Cloud Architect, and No Load Test. For more information, go to www.newco.com or call 703-856-8187.
And we're back. It was a lovely sponsorship message.
Mark, let me mention something about I've got a graph that when I show analysis in our training class, we have a JVM heap usage and garbage collection graphic that shows over a 5-minute period when garbage collection is done improperly, even transactions that happen 1 second from each other will be vastly different. And that's how I can really hone in on JVM problems, because the first transaction will be 1 second, the next one will be 30, the next one will be 15, the next one will be 2,
right,
and it's under the same load. What's your thoughts on that?
There's a lot of behind the scenes garbage collection, or well, I guess garbage collection is a bad word here. There's a lot of mechanical behind the scenes that goes on when you're using the Microsoft Foundation class libraries in Visual Studio that force good practices as far as cleanup of objects. And now if you have hand-tuned code, you're going to see more of these issues inside of .NET, but still they're enforcing in the base classes a lot of things that will get you in trouble in a more hand-coded universe in the Java, particularly Java virtual machines. I'm more old school. I like to allocate and deallocate raw right at the operating system for performance reasons. Mark?
Yeah, I'll say in the .NET versus Java garbage collection world, Scott, what you're talking about for the most part is what are the defaults? So what are the defaults that really, when you're building a .NET app versus building an app on top of Java, it's the default configuration for the Eden memory space, which is like the fastest Eden, usually loaded into the processor cache memory space, the first generation of very small objects that you think aren't going to live very long or are very small, they go in Eden. And if you can get all of your GC work done in Eden, then it's going to be very, very fast in order to get your work done. And so the concept of Eden, or that G0, generation 0, the defaults in .NET versus the defaults in Java are different. And it's just a preference. So if you're in the Java world, usually you spend more time tuning Eden, the space, the memory allocated, so it fits the physical architecture. If you're in a virtual machine world, then you got to make sure you're following the best practices from your hypervisor or whoever the vendor you're using. The other counter, one of the things we should talk about for garbage collection, is looking at the percent time in GC, which is how much time the user mode process spends asking the system mode process, please, JVM, please go clean up my code or clean up my object. So if you look at percent time in GC, .NET versus Java, again, a lot of the discussion there is around how .NET figures out if there's a threshold. Am I really spending too much time in GC? And could I even disobey my rules for automatic garbage collection and the number of threads and actually either defer a little bit more or not based on how the code is configured? Whereas in Java, it's just sort of, as James points out, it's kind of agnostically coded and you have to go in and tune JVM. Which brings us to another part of garbage collection tuning, which would be around having parallel GC. So James, parallel GC is like if I can afford as an application to have one minion, and one minion that goes and takes out my garbage for me and does my garbage collection, I have one GC thread. You can get only so much garbage collection done one thread at a time. So if you actually have lots of little objects, OLTP, e-commerce, lots of throughput, lots of little objects, you actually need more cleanup in parallel. Let's say I find that I'm spending GC is falling behind and I'm hitting stop the world, which means I can't do enough garbage collection to keep up. I may have 1,000 active threads, but I only have 1 or 2 GC threads. If I parallel the GC threads, I could get maybe 8 parallel GC threads, enough to keep up with cleaning up those objects, but not push the system too high, let's say less than 20% time in GC. So you can have more threads. That's just like any other thing. You can have, multiple minions, and they can get the work done faster, and they can get it done in parallel, which means you're not waiting around, and you can avoid stop the world. But the tricky thing here is if you throw, let's say 16 processors, and you have 16 parallel GC threads, suddenly you may peg all 16 processors. They're all doing GC work, and they'll stop the active processing from working. So you got to get this balance. It's usually less than the number of cores or less than the number of instances of schedulers within the JVM. So you want to, maybe 50% of the processors on a 16-way have 8 parallel GC threads, maybe 12. There's no one right answer. We do have to tune it, try it, test it, scale it up, see how it does, and see how much time is spent in GC and see which one gives you the most optimal thing. That's how I would go after that.
Hey, Mark.
Yeah.
When your minions are done garbage collecting, can you send them down to my house? Because I have some rooms that I need to get painted.
Yeah, they're actually good with gardening, too. They have a green thumb, those little yellow bastards. So that's sort of garbage collection. And I think, James, we should bring up the old 100 by 100 rule.
Yeah. We will not name this this e-commerce site, but they were the victim of a rather poorly configured monitoring script.
Like an APM script, like a synthetic monitoring script in production.
Yeah, you should, A, do no harm. You don't want to influence the performance that you're trying to sample. And B, you should follow best practices for whatever you pack in, you pack out. So if you create something, if you put something in a shopping cart, you should remove it so you're always in the same state every single time. Well, for this particular customer, what happened is they had a poorly constructed monitoring script, which would simply add something to the cart and time it. Well, over hundreds of thousands of incidents of doing that,
months and months,
you wind up with a cart which has 100,000 items in it, 100,000 objects for memory management. It gets loaded once every 10 minutes, and then when it needs to be unloaded, what do you think happens?
You have to garbage collect all 100,000 objects.
Stop the world.
Stop the world. So our 100 by 100 rule, which is for every holiday when you go into it, is what, James?
Anything more than 100 days old that hasn't been purchased, purge it.
Purge it from the cart.
More than 100 objects, either purge the cart completely or trim it to 100 objects. You want to eliminate the risk associated with one of these unusually large and complex carts being loaded into memory on your highest traffic shopping days. And Mark, what happens when you have response times that go above 2 to 3 seconds on a site?
Abandonment. You're done.
Exactly.
You're in e-commerce. You're not making money.
And that customer, according to studies, is likely not to return to your site until 4 or 5 other sites also have negatively impacted their user experience, and then and only then will they come back and take a look at your site.
Absolutely. Here's the other tip I'll say. What's preventing your competitor from actually opening a fictitious account, never buy anything, and just load up a bunch of carts, and on Cyber Monday, at your peak hour, your competitor goes click, 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 boom, and your website is down, and they get all the business. I mean, that's major.
Absolutely nothing stops them from doing that because it's legitimate business activity. It might occur infrequently, so infrequently that they can't figure out why it's happening.
Yep.
And then all of a sudden on your highest shopping day, it's industrial sabotage. That's exactly what it is.
Just kidding. It's time for the News of the Damned, right? At the bottom of the hour, it's time for News of the Damned.
Hello, PerfBytes listeners. It's your old friend Satan here. It is with great esteem that I'm proud to introduce this week's edition of the News of the Damned.
Can you dig it?
Okay, Mark, it's time for the news of the damned.
It is.
And let's get started with our favorite person in the universe, Princess Kate.
Princess Kate, Duchess of Cambridge, always joining us.
I have perhaps a poll question for our listeners.
Yes.
We now have Prince George and some of his fashion decisions that are crashing websites. Do we need to track Prince George independent of Princess Kate for our Person of the Year?
What do you think, Scott?
I think they should be separate. Yes,
Should be separate.
Okay.
I think that
in this case, Prince George and his fashion decision for his baby blanket, his swaddle blanket, has resulted in the manufacturer's website for that blanket being crushed with load and going down.
Can we call it Swaddlegate? Swaddlegeddon?
Swaddlegate.
Swaddlecraft?
It's a New York-based company, a Nace or a Nice or something like that.
Yes.
I'm sure I'm butchering that name. And just in the couple of minutes after the picture of the blanket went up and online, you're looking at 7,000 orders, a 600% increase on that one item.
600%.
And just imagine what would happen if that site had been up and they'd been able to take more orders.
That company, they could have retired.
Yeah, I think they need to prep for having a team stand by for unexpected load. And I think really when you get a royal charter these days, there needs to be an insert on preparing for extra web load.
Yeah. This is the thing with online sales. You might not know if someone famous just bought something, right? If you were in a store in Beverly Hills, as I often am, you'd see celebrities come in and so-and-so just bought a so-and-so and you would know it's happening. Now you don't have no idea that, they just bought that swaddle and, Swaddlegeddon.
Okay. Item number 2. On July 15th, we heard that there is a new Doctor Who.
Yes, there is.
Rule number 1 for anyone who watches Doctor Who is the Doctor lies.
Yes.
Rule number 2, the Doctor doesn't know how to provision web servers. Perhaps he should ask a cyber planner for assistance on this. So the 12th Doctor is going to be played by Peter Capaldi. It was announced a little bit earlier this month. And, of course, the official Doctor Who website for all the interest around the world went down under load. They knew. They were very well aware of what the interest would be. They were in total control of when the information was going to be released. They were in total control of how to prepare for it. There's really no excuse for why they didn't have information pre-cached around the world, seeded for when these requests came in.
Yep.
And there's really no excuse for not having a high-throughput website designed just for this event.
Yeah, I agree. Totally inexcusable. And the fact that we are still talking about it means that the Doctor did not go back in time and fix it because we're still talking about it.
True.
At least on this timeline.
There's that whole thing about the Doctor crossing his own timeline. And, some points in time can't be changed.
Yes.
And, I get confused. But, it's an entertaining show.
Yes.
So this now we're off to concert issues.
Concert tickets!
Yes, and this one actually is termed "Oh Shit."
Okay.
And the reason why it's termed that is because that is the comment from the founder of Bang Tango, the Australian ticket brokerage firm that was selling tickets for Bon Jovi this summer. This was the first big test of Bang Tango.
Yes.
The Bon Jovi ticket sales, and they failed.
They failed. With a name like Bang Tango, you can't afford to fail.
Yeah, and this leads to the cardinal rule, which is functional is easy, performance is hard, point load is really hard.
Yeah, it's really hard, but
and it takes a culture of performance to get it right.
Yes, and in better news, good on Bon Jovi. They still got it. Rock and roll, man.
That's true, and it's not like they weren't going to sell out the concert. It was just going to take a little longer.
Yeah, exactly.
And of course, we can't have a discussion on concert ticket sale failures without a discussion involving the UK.
Yes, agreed.
This was a festival, the Cumbria Soul Fest. Demand for tickets at the festival at Tarnside Farm near Aspatria,
yes,
to be held over the August bank holiday weekend, surged due to a News and Star e-voucher sale. So we have a marketing event which drove extra load to a website. Do you think there was any coordination there, Mark?
Dude, I tried to call you, but I was like, I was so busy. I mean, there's this campaign I'm doing, and we were reading the tweets, and I was building the tweet sheet. I don't know. I mean, don't you guys have something in IT that just takes care of this automatically?
I think that was about the extent of the conversation.
Yeah. Exactly. Mm-hmm.
Yeah, according to Malcolm Irving, the e-vouchers manager for the News and Star e-voucher program, quote, "It shows how the e-voucher system is becoming so popular and people are looking out for more. We have dealt a lot with festivals this year, and it has been great." Of course, totally ignored the whole cause of the issue, but he also did apologize for those who missed out on tickets and caught up in the crash. And he's hoping that their vendors are looking to expand so this shouldn't happen again.
Yes. So that's in proper British fashion. That's a very diplomatic answer.
Yes. And I think this leads to a market opportunity for someone who can produce something for festivals and state fairs. And I recommend Burning Man for a test drive.
Ooh. So that's the news of the dam. James, thank you so much. That was marvelous. And now we've got two royal members in the News of the Damned leaderboard, Princess Kate and Little George, right?
Yeah.
Yeah, very cool.
We're not supposed to say Boy George. It is Prince George.
It's Prince George. All right, let's talk about the caching aspect of memory. Let's say I have to make a round trip to get my account information from Amazon, and I'm looking through a bunch of things, and I download a bunch of images when I'm shopping. Right? So I'm on the page and I'm looking through a bunch of stuff. And the next time, like, I'm just investigating my e-commerce experience, right? What am I going to buy? And then I kind of go back and forth on a couple search items, and then I put some stuff on my wish list. You know what? The major decision I'm going to make about what I'm going to buy is sort of guided by, let's say, the static content, the images that are being loaded, right? Well, that image, when it makes it all the way down to my browser, it had to come from the entire back-end system. Who knows? Somewhere way in the back, the merchandising, the product catalog people decided, here's the image for this product, and it's going to end up in my browser, cached in memory, so that if I'm flipping between tabs and trying to look at different pictures, it's really, really fast because it never has to make a round trip all the way to the back end, right, across the network. But let's say I clear my browser cache, James. Do I have to where am I going to go to get all of those images? Am I going to go all the way back to the product catalog in the database?
Well, let's think about this. Okay, the reason why you want something cached is so you can access it in a quicker fashion. In the case of a browser cache, it's actually putting to disk locally. But what you're doing is you're avoiding a more expensive interface method, which is going across the network. Network is always more expensive than local disk. You're also, from a performance perspective, allowing that information to be stored locally so you don't have to re-request it, and you've avoided that server load associated with that request as well.
Right.
So on an individual basis, it might not be very expensive, but you have thousands of people requesting the Amazon logo, and then all of a sudden, the server goes down, or the servers go down, just under the load of the logo and the style sheet and other components which are not changing. So you clear your cache, you're going to have to go back and get those items. There are some items that get cached for very long periods of time.
Yeah.
Fonts, as an example.
Mm-hmm.
They may not change for years, and so the cache age could be years on them. A style sheet might have an age of a month.
Sure, whatever the iteration or releases are, yeah.
Something else might have an age of your average session duration.
Yep.
10 minutes, a JavaScript file, just so I don't have to re-request it every time it's referenced on a page.
And in the web world, James, this is like HTTP what they call cache control headers, right?
Yes. And this is an extension of just the caching model that goes all the way back to the level 1, level 2 cache for a processor. It's faster RAM, it's local.
Yeah.
I get to it easier, and as a result, I have higher performance.
Yeah.
and or caching of query results in a database server because it may be looked up by somebody else, or caching of a couple of different pages because there may be a likelihood that I'm going to request data on those pages.
Yeah. So I think the example that you brought up about caching query results really gets after how memory helps optimize the performance of these data movement transactions. The same thing is happening. Let's say we get create an object. The object is a string object, and it's going to have a query result. So I query the database, and it comes back with my address. And I'm on the app server, and I create that object, and the object is in memory. And when it first gets created in the processor cache, like you mentioned, L1 or L2 cache, if I go to the database and I take a slow transaction all the way to the database to get the address information, it comes all the way back, and there it is on the app server, and it's in that object. As my session continues, sitting in the JVM is my little address string object. As long as I have like 2 or 3 other people accessing that object, it's going to stay nice and hot in that local memory. Really fast, taking advantage of that processor cache. So there's caching at the very low level of even the hardware processor cache, the actual caching coprocessor, caching on the database itself. There's caching even in the network card. So we should be really clear about the fact that we're talking about cache, C-A-C-H-E,
Yes.
not C-A-S-H, the English word for muchos dineros. So James, you wanted to talk about sort of database caching or pinning table entities even in memory. You can do that, right?
Yes, absolutely. Now, there are a couple of things that databases do in order to improve performance that are directly related to caching concepts. One is they will try to take your result set and they will cache it for a period of time just in case someone else makes the same request.
That's smart.
Yeah, so that way they don't have to incur the cost of going to disk, pulling all the data, and then after a while, if no one else requests that data, it will age out and it will be purged. And then there is a way that you can educate the system to work to your benefit by taking advantage of memory for the storage of tables as opposed to storing them exclusively on disk and looking them up. If you have a very often looked up table, a lookup table, think of it as states, zip codes, states, cities, something that's going to very effectively fit into RAM but is hit every single time. Scott, I know your website, you do GeoIP lookups for every user session coming in, so that this could be a good example of a table that's hit all the time consistently. How about you pin that table in RAM? RAM is always going to be orders of magnitude faster than disk for lookups.
How do you know we don't do that already?
I don't. I absolutely don't know that.
We actually have it set up, and I'm not giving away any trade secrets here, but we just have it as a binary table, so it's on or off.
Yeah.
So it's pretty quick.
Right. So the concept of caching, to monitor this kind of stuff, you can look at something in SQL Server. I think it's page life expectancy, right? So if you're caching a page, an 8K page in SQL Server, you're basically saying, how long do I think that page is going to hang around in memory before it gets flushed out or it's going to get reused? So you can look at something like page life expectancy. You can look also at, there's a cache manager within the SQL Server engine. There's also equivalents in other RDBMS as well. But that's a good way to see how much, are we doing a lot of work within those caching objects, the number of objects that are cached, how many of them are getting sort of cleaned out or reused. If you have to go to disk, the cache hit ratio, I think, is the other one, right, James?
Yes.
Yeah.
Yes. And in fact, if you have a transactional system where you have users coming from all over the planet and a lot of their data is not on adjoining pages of data in the database and things of that nature, you might have actually low cache hits on a lot of the user information, but you might have high cache hits on things that they're looking up. For instance, if you have an advertising campaign going on, which is directing people to certain pages and certain pieces of information, you could have high cache hits on that,
right,
but low cache hits on the actual user session information.
Right.
and hopefully you get a high cache hit ratio on the planned cache.
Right. So the thing to keep in mind is that it's not the panacea, right? You can't just say, well, that system, the database is slow, so I never want to make a round trip to the database, so I'm just going to cache it. And it's not it's not something you just do all the time. And here's why. If the only thing you have, the only mechanism, the only solution you have to a performance problem is I cache that information. And let me tell you, cache, the minute you reboot the system, it's gone. Memory, gone. So when you bring the system back up, if you're under major load in your peak hour and the system has to reboot or for some strange reason something else goes wrong, if caching is the only thing you're doing to try to meet your SLAs, you're going to blow your SLAs. In fact, you might even blow the database over if you've just over-cached everything. So don't use it as a total panacea, but use it with some priority. These are the top 10 objects that we need that are very, very serious, and caching isn't the only thing we do. Maybe we even take a local copy and save it in disk as well as being cached in memory. Maybe there's some other things. If the database completely goes away, if you're using a third-party data source, do you have a local copy? So think about it not just the only thing you've done for performance optimization and caching something in memory. And then the second thing I'll say is just when it comes to tuning cache, you need to tune when you're under realistic load. So if you tune the cache and you just have one V user, hitting really, really fast, but you're not testing for, 1,000 V users or some multitude, if your load simulation is not realistic, then your cache tuning is going to be worthless. So if you're going to go through a cache tuning exercise, make the investment in getting a more realistic simulation of the real world. All right, let's get back to talking about memory. There are two other really interesting and important things, sort of almost the opposite of point load is sort of the long-term soak test load we've talked about, James, and how to test and monitor for memory leaks. And actually, Scott, you brought this up as well. Have you recently done any sort of memory leak testing, Scott? Actually,
we do it on almost every project that we do as part of our methodology. That towards the end, we do some kind of it's usually a minimum of 8 hours. So it just so happens that falls in from the 5 p.m. time zone till the 8 a.m. time.
There you go.
Time that we come back in. But no, it can go as long as 24 to 36 hours, depending on what the client needs.
Right.
Something that I found very useful when looking at these long-term tests is instead of involving the entire architecture of the app, is to try to go for a slice. A tenth of a slice. One node of each type, and then run the load at slightly hotter than what that slice would dictate. So if it's a 1/10 slice, run it at 25% to try and exaggerate the impact of what would happen on a memory on a shorter scale.
I'll tell you the one thing, if you're not really familiar with all of the components that are underneath your app, and if you're working in .NET or Java, you probably aren't in touch with everything that's happening. And so memory leaks can be kind of elusive. And a lot of people are like, I don't know, the operating system's doing something. Don't you know what's... I mean, there can be a lot of mystery about it. But the truth is, it is very mechanical. And to your point, James, if you have a 10% memory leak over a 1 hour run, if you double the load, it should be a 20% memory leak over a 1 hour run. So the idea that it's a fairly mechanical thing, and watch out for things that loop. So whenever you create something and you don't dispose it, whenever you allocate memory and you forget to deallocate it, whenever you're using maybe a third-party component and you don't have total control over how that component manages its memory, when you've got all this stuff moving in play, everything that has loops, that's where you're going to allocate and deallocate memory, allocate, deallocate memory. And also looking at, from a memory leak standpoint, the duration. So you can't just do like a no think time run, which my mantra, James. No think time equals no thinking. You can't do memory leak testing in that same approach, right? So if it runs in 15 minutes, you think, oh, that's great. Last night it ran in 20 minutes, so we're 5 minutes faster. That's not really how you do this kind of memory leak testing. You need to have a longer duration because sometimes these are very minor leaks. And you want to monitor things, and Scott, you brought this up before, monitor things like obviously the available bytes. So if the kernel is actually giving up more and more memory to your process, as well as private bytes. Scott, I think you mentioned private bytes, right? That's within that process, right?
Right.
And so you're looking at what is private bytes?
So the amount of memory that the operating system is reserving for itself, which it's not going to share out with other applications.
So if you have heavy kernel-related activities such as memory management, I/O, things of that nature, that private bytes is going to grow. And as you have memory that is locked up and allocated,
it's less for your applications to use.
So the idea that you want to have some kind of throttling, some kind of pacing, like James says, a little bit hotter, maybe not a 2x test, maybe 1.5 or a little bit hotter, and do a slice of the architecture because memory leaking, that code, if it's the same, if you have a scale-out middle tier, scale-out web servers, scale-out app servers, and try to do a single slice because you'll see the same incremental increase in memory usage over time. And you just said you do overnight runs. I recommend a 12-hour run if you can afford the time to do it. Because I'll tell you the other tip on memory leak testing is since so many people really don't get how to do it and it's oftentimes not done, if you want to really have people who don't understand computers buy into the idea that this is an important problem. If you run something for 2 or 3 hours, you'll have ops guys that are like, oh, well, whatever. That's a problem.
But Mark, if those same ops guys reboot their servers once a week because of memory issues, they ought to want you to run these long-term memory tests so you don't have to reboot the server.
Yeah, that's my point. That's just like if you run some significant duration, think about who's going to pay attention or stand up and go, oh, you ran for 12 hours? Yeah. And you found that? Whoa, that's probably the same thing that's making us do a rolling restart every week. But it's the same kind of thing, right? So know your target audience there for sure.
That's exactly what used to happen to me when I worked at a company. The one team that never wanted to take the time to do that final memory leak test were the ones that were getting, paged at 3 a.m. in the morning and wondering why every 3 months they were rebooting their servers.
Exactly. And so you can win an advocate for performance if you can say, hey, would you guys like to have the weekend off?
Yeah.
Because these systems, we're going to test them for 72 hours, and they're going to stay up for 72 hours. So you can go fishing on the weekend, which is always really good. Memory leaks can happen not only in the application under test. Memory leaks can also happen in your testing tool. You can accidentally custom code in a load runner script or any testing tool. And your custom code, if it's not disposing objects correctly, if it's not freeing up memory and putting it back in the stack, that's going to be an issue. So you want to monitor, as we pointed out, available bytes, private bytes. Also, the heap percentage, what heap is used. If you have plenty of Eden space, if you have the primary generations, if you have within the total pre-allocated memory for your JVM, there's going to be what's the size of the heap. So let's say you're using Dynatrace, you can see a nice graph that shows, hey, I'm about to run out of heap as we scale up. Memory leaks from a performance test standpoint, I'll also say, these are usually steady state long-term load tests. So go back to our episode on types of performance tests, and you can hear us talk about soak tests, which are, you don't want to be scaling up and scaling down and scaling up and scaling down. It's not a workload test or a scale test. It's more of a steady state, and then repeat that thing over and over again for hours and hours and see what you get. All right, this brings us to the closing segment of PerfBytes today, which is Ask PerfBytes, the viewer mail question and answer session. Scott, your first question is,
how can I use these same techniques that we've been talking about to find out what the footprint is of your load generation?
Okay, so this one is pretty common, and James, you probably have heard this about the other tools. There was a big thing in competition about like how many V-users, load runner versus tool X, Y, Z, could be the most efficient and, run the web virtual user and its really, really small footprint. the interesting history here is I remember some of that competition. I don't know if it was Microsoft or Segway. Remember Segway a long time ago? They actually ran an empty web virtual user with no code in it. And they wanted to compare the drivers just without any calls, recording, like an empty script. And that's what they were going to compete on in the sales process. And I remember showing up late to the conversation, and I basically said, that's nice for salespeople. It has nothing to do with the real world where no script worth any value to a company. It's all got calls in it and code in it. And what we're actually talking about is how many web URL calls you have, or how many, web submit data forms and the form submit and all this kind of stuff that you're putting in there. So the first thing I'll say is, from a footprint perspective, run one virtual user of your normal script, right? With the code in it, with the parameters the way it is, and run that for, let's say, 5 minutes, and then open up perfmon or open up top and measure for that virtual user how many, private bytes for that process. But the MDRV, the M drive, find the MDRV exe and actually measure that single virtual user. But don't just do the math off of, let's say, that single MDRV. You need to do like one virtual user, then do two virtual users, then do three virtual users, and start there and say, all right, what is the per virtual user footprint for that protocol, for that script? And each script is going to be different.
Mark, extending this out to various tools, you want to take it out to 10 and 25 and 50 as well, because depending upon your tool, it may fork another instance of the driver program.
Right. I was just going to get to that.
Depending when you get out to the 10th or the 11th or the 26th.
Right. But my warning on that, James, is that you would want to do those as separate tests. So if you do 1, 2, and 3, and 4, and maybe 5 threads, you're doing a per virtual user memory test. And then you want to do maybe a 25 and a 50, or a 10, 20, 30, 40, 50, because the default for MDRV and LoadRunner was 50 threads per MDRV, so you'll get up to 50. Do the per virtual user thread, because you don't want it to end up being an exponential curve, right? You don't want to go 1, 2, 3, 5, 10, 30, 50. So that would be exponential, and then your trending looks really weird. It's harder to do. It's harder math, and I don't like math. So keep it simple, I think, Scott, in that perspective. Each script is different, even though they're the same protocol, and then each protocol is different, and even versions of the protocol. And
not only that, but your developers, if you take any two developers side by side, they may be different depending upon how great or how poor a developer they are, and how efficient they are in the use of resources. My premise is, we're performance people. We should be using best practices in how we build our own code for our efficient use of resources. But the problem is, the industry has decided that having those foundation skills in development is not necessarily true. I disagree with that, but that's just me.
Yeah. So really, the performance engineer really needs to get his footprint just before he starts doing his test for that test, because it's based on the script, it's based on the protocol he's using. So that's when you should get your footprint, and then advise everybody accordingly at that time.
Not just from a chart that the vendor gives you.
Exactly.
Because it's EPA, your mileage may vary.
Oh, yeah, especially we measured that mileage when we took all the seats out of the car, and there was only one person who weighed 40 pounds in the driver's seat driving when we got the estimated fuel. We didn't fill it up with all of our stuff on a road trip like we do. So, yeah, Scott, that's a really good point. It's also this is something you should be measuring, monitoring your load generators during a smoke test. So, I know we're only going to run 10% of the load in our first smoke test. Well, what if I'm out of memory on my load generators, even in my 10% smoke test? I got a problem. And I think with any of the scripts, any of the tools, it comes down to parameters and buffers. If you've got a lot of variables or a lot of structures, strings take up memory. So if you're moving a lot of parameter data around in the script, correlating that view state is probably the most common one we see, any kind of state variable.
I love a .NET view state-based web virtual user script that I audited a few years ago. There was no reuse of memory variables. There were large view states, and by the end of the iteration, every virtual user was about 75 or 100 megabytes in size.
Oh, yeah. And you can see the same thing in the Java world, same moving states or caching. If you deserialize an object, but you don't throw it away in the script, in the JavaScript, yeah, it'll just keep growing like crazy. So all the same things for tuning your system under test, you can tune on that as well. All right, we have a couple other questions in the PerfBytes inbox here. James, this one comes from Lloyd in Dublin, Ireland. I love this. And we've seen this a lot on the forums, actually. I've been told that LoadRunner cannot measure the web GUI rendering time, the browser rendering time. Is this true or false? And if it can, how the hell do you do that?
That's an interesting question, Mark. And I guess first we need to cover what is rendering. There are a couple different definitions out there.
Yeah.
The W3C, the World Wide Web Consortium, considers rendering the act of drawing an object on the screen.
Right.
That is what is rendering. And in fact, you can look in a lot of browsers and the developer tools, and they will show you the network time, the processing time, and the rendering time of a given object.
Yep.
And the rendering time being what it takes to draw on the screen. Although it seems like the more common definition in use in the performance testing universe is the time completely in the browser, which includes DOM processing, which includes JavaScript processing, and then finally putting information on the screen.
Right.
The classic old tools, Rational, Borland, WasSegway, HP, so LoadRunner, Rational Performance Tester, Silk Performer, they have had this capability since version 1 of the tools. It's called the GUI virtual user. You run a GUI virtual user, then you run an API or transport layer virtual user for the same timed transaction. Logon is a classical one. So I have a login underscore GUI and a login underscore HTTP or a login underscore database or whatever, and I subtract the averages of those two, and I'm going to get the time spent in the client. And that in the client could be a thick two-tier client. It can be a web client with a thick interface on it, but I'm going to get the delta between those two items. And so you got to be very, very careful what you mean by rendering in this case.
I think the best advice you give there, James, is there is a proven technique. And basically, if you know the customer, the end customer that says, I want to know the time it takes to draw pixels, then you need a tool that does full visible browser to draw pixels in order to measure that time. And so the old school way we did it, and you could do this with Selenium. You could do it with JMeter. Actually, the JMeter plugins now supports WebDriver and Selenium. You can run a single virtual user, full visible browser, still automated, but you run it alongside your load test and you take full pixel rendering. Another question, Carson from Boca Raton, Florida, actually writes in a question. Help, I've been assigned to run a performance test in next week's sprint. I've never done this before. What tools should I use?
I'm going to leave this to Mr. Moore. My best recommendation would be to pick up the phone and call someone who's done it before.
Yeah, call Scott.
Because the phone is a tool, but Scott, what's your thought?
That's the best way to do it, is to call somebody who has actually done it before. Because if you've never done it before, most likely you're in an agile situation where you're most likely a developer, or you're maybe a functional QA person who's been assigned that role, and you stay in that role every sprint. And now you've been assigned to do performance testing. And the one thing, whether you're in agile, waterfall, whatever methodology is, performance testing is still a niche skill set. And you need somebody who is a performance engineer, not just a tester. And this is what you guys talk about every single week. So somebody who understands what to look at from the back end perspective, from the, we're talking about memory today, network, disk, CPU, and also that client rendering time that you were just talking about, being able to marry the two and finding out why one affects the other.
Scott, just give me a tool, man.
Yeah.
Just give me a tool.
But if you're going to see, full disclosure, I'm an HP reseller.
There you go.
So I'm going to recommend LoadRunner.
But it's true. And with the most companies, I mean, first of all, ask around your own company. Is somebody else already doing performance testing and they can help you? At the same time, has your company already bought a copy of LoadRunner? It might be sitting on the shelf and no one's used it. And even though you're in love with your Mac OS X, go fire up a Windows VM and start writing some scripts in LoadRunner. You may already have the licensing you need in there. If you don't have a commercial tool, just from my personal experience in the last year, I've been using JMeter and the JMeter plugins. That's a good place to start if you have no other access to any other tool. And so to answer the question, what tool should I use? The one that's most accessible to you from a financial and a technical perspective. But secondly, the one that fits with the app. So this protocol, I know how to code in it, and I have the licenses, and that works with my web app or web services, or if you're coding Java API calls or whatever you're coding, database directly. All right, the last question we have, this is Ron from St. Louis, Missouri, who writes, what makes mobile performance testing so different? Are there different tools or things to do? What makes mobile different, James?
Latency.
I think latency is the biggest one. If you kind of, it sounds like Ron knows what he's already got familiar with performance testing, maybe classic load testing of systems, and he's just like, well, what makes this mobile stuff so different? Latency is probably if you did nothing else to try to tackle a mobile app, latency is a great place to start. Get the Shunra stuff. Get the other mobile. There's a couple of some open source emulators or delays. There's some stuff you can put in. And start profiling that. The other thing that makes it different is that there's a tremendous amount of pressure to keep the client really small and move very small amounts of data. So not just latency, but let's say somebody says, well, we're going to make our app mobile, but they're still moving 1 megabyte per second to the client because they have these huge data structures. It's an old fat client or something. If just think about throughput as well, not just from a latency perspective, but I mean, if you have an app that's really fat on the wire or makes lots of app turns, that's something you can investigate. Even if it's just a normal browser app and you're going to load it on a browser on an iPad, it's mobile now, and it may be going over a 3G, 4G LTE network. Boy, app turns, throughput. Go back and listen to the PerfBytes episode on network performance. We talk about latency and reducing the number of app turns. Caching, we just talked about caching stuff on the client side, so making sure you're testing for cache control headers and make sure everything gets cached properly in the client so you don't have to make that many calls. That would be a good idea. The other thing is the client is incredibly unreliable from a connectivity standpoint. So testing your application to drop a connection, reestablish a connection, and continue that session seamlessly. Don't just, I lost my connection and boom, I need to start over. Any workplace productivity app, you can't disrupt the business flow, right? You have to be able to work mobile and seamlessly, so it doesn't session dropouts and having to reestablish a session, security.
That's the big one. Dirty apps from a size and number of flows. Mm-hmm. Not caching appropriately, high latency networks,
Yep.
assume that you're going to have connectivity and transmission failures. You almost have to assume the worst of all possible conditions when you do these types of tests in order to get a good performing app.
I also think you've got a diversity of devices. So you've got different processor speeds, some of them single processor, single threaded, some of them do have multiple processors or multi-core, different speeds of the flash RAM or the RAM memory or storage that's available on the device. So you might have to pick your top 10 devices. It's not just a back-end load test of network and server under latency, although that's probably a great place to start. You pick up those top 10 most common devices that you want to run the app on. They're going to have slightly different performance on each one. Then they're going to render differently, all that kind of stuff. All right. So thank you to those, Lloyd, Carson, Scott, and Ron, for sending us. If you'd like to send us an email at PerfBytes, just send it to ask, at perfbytes.com, and we will entertain your question on the air and do our best not to muck up an answer, because we really don't know what the hell we're talking about anyway, to be honest. I don't really. I don't know. And that's about the end of our actual episode here, James. Any closing thoughts on memory that you want to remember? Did you forget anything? James forgot everything he ever knew about memory.
I forgot. No.
Scott, any closing thoughts on memory? Did you learn anything as our guest?
I did, and I have to say, I listen to your show. I know I'm a participant, but I listen to your show every time it comes out. Whenever I'm exercising, I walk. I try to walk about an hour every day. I listen to the previous episodes, and I learn so much from you guys. And the fact that I know that you pull this stuff out of your butt every week, that you do this, just tells me how much you have stored up in there that you've probably forgotten more than some people will ever remember. So I'm very privileged to be in your company, friends. Thank you.
Absolutely. Actually, much of what James used to know mentally, he swapped out to disk, and then he lost a disk drive.
That's what it is.
It dropped a spindle way back in the end. So to give you again, a recap of the things for memory, just so you guys can remember what it is we talked about. We talked about garbage collection, getting a bunch of little minion threads firing up to go collect all your old garbage, and try to keep your %GC under 20%, and try to avoid stop the world. If you notice this blackout of transactional throughput, you might need to tune your parallel GC threads. We talked about caching, right? Caching memory, putting data into memory so that you don't have to make a round trip back to the database or the disk or wherever it was you got it from, and being able to get everything from cache control headers to caching plans in the database would be really good. That's PerfBytes memory for you. Thank you again, of course, everyone, for tuning in and listening to yet another fantabulous episode.
This
of PerfBytes.
episode, according to the PerfBytes website, has been brought to you by kettle corn.
Kettle corn. I like kettle corn. It's great for the summer, don't you think? It's a good summer festival.
It's appropriate.
It's very appropriate. That's right. And just a reminder that all of the contents of these PerfBytes episodes are copywritten and protected with a padlock that you lost from your third grade gym locker. I think the combination, we were just at Black Hat, I think some guy gave me the combination, was 633 16, something like that. One of the two, something. And of course, you keep in mind you can always listen to PerfBytes online on iTunes. You can follow us on the Facebook page. You can follow us on Twitter at PerfBytes. We have a Tumblr feed. We're now on Quick. You might actually see some videos on Quick posted out through the Twitter channels. James is on the road. James, where are you headed to next, actually?
I am headed from the Nashville recording studios of Scott Moore to St. Louis, then on to Colorado Springs, Santa Fe, and I will be on the West Coast in about a week. So I'll be in the San Jose, Santa Cruz, San Francisco Bay Area about this time next week.
So
if anybody would like to rob James's house,
yes, please don't do that. That would be very bad.
I am highly secured at home. Thank you very much.
Yes, I will give a shout out. Special thanks to the Irish voice of PerfBytes, who is infinitely vocally supportive.
And I'd like to thank my mother for listening. I know we have at least one listener every show, so I'm very happy with that. And I believe Mr. Moore is going to grace us with some exit music for today's episode.
Scott, give us a little PerfBytes rock guitar. That closes out our show. Well, thank you everyone for listening. We'll see you on the next episode of PerfBytes. And thanks, Scott, for joining us. This was awesome.
Thank you for including me.
You can say goodbye to James. Scott.
Goodbye to James.